Good morning. Today we are going to discuss about metamorphism and its agencies. Metamorphism is the change of minerals or geologic textures in the pre-existing rocks without its melting into a liquid magma. So what actually metamorphism is? It is the alterations in the mineral assemblages or the change in geological texture due to one reason or another in the pre-existing rock. Means there has to be a pre-existing rock whose mineralogy or geological texture or both will change or will alter without undergoing the liquid state. Such process will be called as a metamorphism, and the resultant rock will be called as the metamorphic rock. The word metamorphism itself explains the alterations in the form. When the pre-existing rock undergoes changes in its mineralogy and geological texture, ultimately it attains a different form. And hence, due to these multiple morphs, they are called as metamorphic rocks, and the process is called metamorphism. The pre-existing rock is called as protolith. Protolith is the parent rock through which the metamorphic rock has been generated. Let us see the agencies. There are three agencies which carry out metamorphism. Agencies can be explained in a way like these are the vectors through which the different processes occurs. Say for example, the for the erosion, if you want to carry the sediment, the river is an agency. It acts as a vector. It takes the sediment from one place and took it to another place, and during that process it erodes the sediment. Similarly, whatever processes metamorphism is meant to perform, it has been done through these three agencies. The first is temperature, second is pressure, and third is chemically active fluids. Let us see the first one, temperature. Temperature is the measurement of the heat. So, whenever a rock is exposed to an altered environment with respect to the heat, the rocks adjust itself, and during its adjustment, the textural and the mineralogical changes occurs. So whenever the rock will experience the change in temperature, that means the change in heat, it will adjust itself accordingly. There are three sources of temperature. One is geothermal gradient. Geothermal gradient means it's a natural increase in the temperature as you go down from the Earth's surface. So if you move down from the Earth's surface towards the core, gradually the temperature will rise. And ultimately, if the rocks sinks, it will experience the higher and higher temperature with the depth. And ultimately, it will result into metamorphism. Magmatic sources are the another well-known source for the heat. When this magma intrudes in any rock body, it supplies or it transfers its heat to the surrounding country rocks. And due to that heat, the temperature rises. And ultimately, that country rock experiences metamorphism. The plate boundaries where the boundaries, perform friction against each other. During that friction, the heat is generated and the magma is also generated. And that also can cause metamorphism. The third well-known source is radioactive heat. During the transformation of a parent isotope to the daughter isotope, the heat is liberated. That heat, if it is liberated in an open environment, may escape. But when this heat is liberated in a confined environment of rock, in that case, due to its unescapable environment, it transfers the heat to the rocks and ultimately metamorphism occurs. So temperature is the well-known agency for the metamorphism. It can act individually or it can act in the combination with the other agencies. Pressure. We all know what the pressure is. But here in metamorphism, the pressure is divided into two heads: directed pressure and uniform or hydrostatic pressure. Directed pressure is a pressure which acts along a single direction. So, directed pressure is acted on the rock along a single direction, ultimately develops an entire different results. Say, for example, a rock is applied with a directed pressure. The haphazardly arranged minerals will try to attain a singularity in their arrangement so that the maximum pressure can be afforded. So you can see in the picture, initially the minerals are haphazard in arrangement, but on application of that pressure, they have arranged themselves in such a manner to experience least pressure. This gives rise to the specific type of metamorphic rock. The second is uniform hydrostatic pressure, where the rock is subjected to a pressure which is uniform throughout all the sides and due to which the rock is compressed from all the sides. And due to this compression, the rock actually changes its shape, not shape, its size. You can see in the picture how the mega rock is compressed to a smaller size. The uniform pressure is also called as hydrostatic pressure because in the hydrostatic pressure is usually uniform throughout the directions. The directed pressure is much more dominant near the Earth's surface, whereas the uniform and the hydrostatic pressure is dominant at the great depth. So with the increase in the depth, the rock will experience more and more uniform pressure and lesser directed pressure. And ultimately, they gives rise to different kind of metamorphic results. The third one is chemically active fluid. Here, the rock is subjected to the magmatic fluids, which are developed from the magma, and they are charged with lots of minerals. When these mineralized fluids, it could be liquid or a gas, when attains a contact with these country rocks, there is a certain kind of reaction. Sometimes the chemical active fluids takes the mineral from the country rock. Sometimes they only gives, and many times they performs exchange. Say for example, you have a limestone where the calcium carbonate is there. It can be replaced by the siliceous matter if your hydrothermal solution or a chemical active fluid is charged with silica. So wherever there is a magma, it will definitely gives rise to some magmatic fluids. And due to their high temperature, they will always try to escape out. And in this process, or during that escape, uh, whatever comes in their way, they will react with them, and ultimately, metamorphism will happen. If the fluid is of liquid nature, then we can call it as a metasomatism. If the fluid is of gaseous nature, we can call it as a pneumatolysis. Though the chemical active fluids are not much dominant as compared to pressure and temperature, but still they have a noticeable proportion in the metamorphic rocks. This slide or this screen will show you that how the increase in temperature and increase in pressure will give rise to the metamorphic rock. As shell is the sedimentary rock, slowly increase in temperature and pressure, you can see that it converted into slate. Then again, if the process continues, the slate will goes to schist. Then schist will go to gneiss, and ultimately you'll get the migmatite at the highest grade. So if the temperature and pressure increases continuously, you can get multiple stages of such metamorphic rocks. The another slide will explain how the known rocks of igneous and sedimentary origin converts into metamorphic rocks. Say, for example, granite. Granite is an acidic igneous rock, but on it, the application of heat and pressure, it converts into gneiss, which is a metamorphic foliated rock. The sedimentary sandstone, on metamorphism, it develops into quartzite, which is a metamorphic non-foliated rock. The shell is there. It is also sedimentary origin. And when the heat and pressure is applied over it, the slate is developed. It is also a metamorphic and foliated rock. So ultimately, the pre-existing rocks or the protoliths, whenever experiences the altered environment, they tries to adjust themselves accordingly, and as a result, we get gneiss, quartzite, slate, etc., etc. There is a long list of metamorphic rock. So let us take a short revision what we have seen today. Today we have discussed about metamorphism and its agencies. The metamorphism is a change in mineral assemblage or in geological texture in the pre-existing rocks without going into liquid magma stage. The agencies are temperature, pressure, and chemical active fluids. Temperature is a source, temperature is a measurement of the heat, and the sources of heat are geothermal gradient, magmatic source, and reactive source. The geothermal gradient or magmatic source or reactive source will increase the heat surrounding the rock, and ultimately the rock will adjust accordingly, will give rise to the thermal oriented metamorphism. Then we have seen pressure, that how the pressure is subdivided into directed and uniform pressure. And what are the ultimate results of the directed and uniform pressure? Directed pressures are more dominant near the earth crust, whereas the uniform pressure is much more dominant at the great depth. Chemical active fluids, though these are not so dominant as the pressure and temperature are, but still they have a noticeable and considerable metamorphic range. Whenever the magmatic water is escaped out from the magma, they during their movement they reacts with the country rock and ultimately gives rise to the metamorphic rocks. Then we have seen some examples that how the shell can be converted to pegmatite on a continuous increase in pressure and temperature. Then we also seen the well-known transformations of igneous and sedimentary rocks, how the igneous rocks and sedimentary rocks are transformed to the metamorphic rocks. The, the characteristics of metamorphic rock ultimately depends upon the protoliths. So protoliths will decide what kind of metamorphic rock will develop. Say for example, sedimentary shell. The shell rock have a certain kind of laminations, and because of which the resultant metamorphic rock is foliated. But in a sandstone, where the majority of the sediments are of quartz, so quartz don't have flaky nature, and hence the quartzite is non-foliated rock. So there is a lot to learn in the metamorphic petrology, and we'll see in our next session. So thank you very much for your patience listening. Thank you.